Okay. And I'm going to ask Tim to take control in just a minute here, and he will then share with us his presentation for today.
Okay, Mark, just checking, see if you can hear me.
Yep, you're good. Just put it in presentation mode and we're good.
Is my screen's
Yep.
up and you can see
Looks
that?
good. Looks good.
Okay. Thank you, Mark. Thanks for the introduction. I appreciate that. Good morning to all out there. There is a kind of a funny note to when Mark spelled Tom instead of Tim. For years, I've been called Tom in a lot of cases. I have an uncle that I'm from Buffalo area originally, and my uncle back in the 70s, for those who are old enough to be back from then, is that he was a professional boxer, and he was a Golden Gloves boxer in New York State. And in fact, he fought for a light heavyweight championship of the world in the early 70s when I was just a young lad. And I used to go watch him work out. So calling me Tom is actually a good thing for me. So I can go with either way. Without further ado, I'll move forward. So this presentation, I'm going to cover a few things throughout it. You're more than welcome to ask questions. As Mark said, I've been around a long time. I started this business in 1988, and so my focus today is going to be talking about the latest technology from 3M. The brand name is called Cubitron II. You'll hear me reference precision shape grain, or PSG, quite often. Cubitron II has been around now for 10 years or so, but we at 3M are constantly tweaking it. We changed the game of coated abrasives and even Scotch Brite products with the development of Cubitron II as a brand and the precision shape grain products. I'll talk a lot about stainless steel finishing and the processes of doing it. And then what I think is very important that a lot of people don't consider are factors that affect the performance of abrasives. And we'll get into that towards the last half of the presentation. So as I move forward, I'll talk about the PSG, precision shape grain. As you look at this, the picture on the left is Cubitron II. The picture on the right shows conventional abrasives, which we still have. We sell a lot of conventional, which is crushed grain, where you basically crush rocks and they're in different shapes and so on and so forth. And they were great for a long time. We could do different things with it, but they create a lot of heat and are more blocky when they cut through metal, especially. The PSG or Cubitron II, everything is shaped. Each mineral is shaped. If you look at it, it looks like a tooth, if you will, a sharp tooth or a triangle or a pyramid. Every one of them is shaped that way, and it's also designed to break down accordingly and stay shaped, which allows us to cut or slice through the metal. It allows us to cut much cooler, much faster, and last longer. And we've seen those benefits over these years with the Cubitron II products and PSG. So regarding stainless steel, some things, what reasons why people do stainless? Well, corrosion, stain resistant, low maintenance, ease of cleaning, and appearance. Those of you that do it, you understand that. Here's a picture of some products that are out there in the stainless steel industry and manufacturing, and regarding finishing. So typically, people are buying, flat sheets in a lot of cases, and then they're shaping and forming it. Then you've got to finish it. If you've welded, you may have handling marks. You've got to take out those handling marks. So things are very consistent when it comes to finishing on the stainless steel. So typically where we get involved is on the back end. If you go from top left to right, you get your stainless flat sheets, you cut it, you shear it, you bend it, and then you weld it, and that's where 3M gets involved with abrasives. And there are different types of welds you've got to do on the stainless, and it really depends on how you get it. Do you buy it with a pre-finish on it, or you buy it as a 2B mill finished product where you've got to create the finish on it? So in stainless, there are different types of finishes, and 2B is coming from the mill. 2B mill, they call it. It's going to have a very dull looking finish. It's where you now have to apply the finish. And if you're buying it in sheets, if you want to put that first finish on or scratch, in it. People will have a wide belt sander like a time saver, and they'll run the sheets underneath the time saver with a coated abrasive, and you'll put some kind of a grit finish on it, depending where you want to start. It'd be a 60, 80, whatever the case may be. The number 3, 4, 5, and 6, the most common is 4. I've seen some 3s. The number of finishes actually determines where you finish with your abrasives, whether it be sandpaper or Scotch-Brite. Number 8 finish is a mirror, and that does happen in stainless, and there is a process for that, and I'll touch upon that later on in a few slides. But I'm going to go through typical finishing process on stainless steel. Number 4 is your most common. Now I'll say this: you got number 4, your number 4 dairy, where a dairy finish is typical. Where if you take a cotton ball or a piece of pantyhose, nylon pantyhose, and rub it against it, then you don't get any pull. You don't feel any pull. You're checking for bacteria. So number 4 dairy is a bacteria-free finish. But the number 4 finish is the most common type of finish in stainless steel. I'll say at least 90%, if not higher, in my experience over the 32 years. And this is, if you look at this, this is the most common way of sanding and finishing on stainless steel to get to a number 4 finish, or even a number 3, which is a little bit coarser. Your first step is grinding the weld down. And we'll talk about that in a second. And I got a video that hopefully we'll play here, kind of show you a technique. Because working on stainless is a craft. It's different than other metals. You've got to understand, your operators have to understand how to work on it, because you can create more work for yourself depending on what you do, how you do it. But typically for finishing stainless, to get to a number 4 finish, I'm going to level the weld. And the key is grinding the weld down with as fine a disc as you can. It's not something you can go fast and use a 36 grit, but now you're creating all kinds of extra steps. And you're actually grinding away probably too much metal to begin with, and you'll create some dips. So typically with the first step, you're going to go 60 or 80 grit to start with. And then you're going to follow it up with some kind of belt or machine, belt on a tool or on a machine, where you're going to set the grain. And depending on the shape of the parts and this and that, there are various products to use. But you're going to use sandpaper of some sort. It's going to be either a belt. What's pictured here is an expander wheel that goes on a portable tool. But you can also use stroke sanders, where you're putting a straight scratch on your workpiece and getting that linear scratch. That's the second step. That's setting the grain. You're removing the grind marks that are done in step 1 to remove the weld, or handling marks, for example. And then step 3 is Scotch-Brite. It's going to be a certain version of grade of Scotch-Brite, coarse or medium. And we have different types of Scotch-Brite belts that can give you maybe a slightly different look. But typically, the third step is to blend or smooth out the previous scratch. So step 1, you're grinding, you're putting rotary scratches in. Step 2, you're setting the grain, but you're still putting a secondary scratch in. Anytime you use sandpaper, you're leaving a rough to the touch secondary scratch on the metal. And then the third step is the Scotch-Brite, in this case belt, and that smooths it up and makes it very smooth to touch, and makes it past the cotton test or the pantyhose type test, looking for any kind of snags. That's what the Scotch-Brite will do, make it nice and smooth. And then the fourth is we don't call it a step, because sometimes people use it, some people don't. They'll take a Scotch-Brite hand pad, put it on a hand block, and then do some final touch-up. Could be some blending of some start and stop marks, depending on what kind of tooling you have and how you do it. That's usually the fourth step. So here's some common welds, flat on corners. And again, various tooling, from 7-inch grinders down to 2-inch roll-lock, depending how big that weld is and how wide it is. So for us, that's step 1. This is where PSG comes into play. And we've got a couple options for stainless steel. The one on the left is 987C. On the right side is 787. They're virtually the same. It's just on the one on the left, we have more ceramic aluminum oxide or PSG mineral on the disc itself. They both have what's called a grinding aid, which allows to run cool, which is critical for stainless. You don't want to create too much heat. If you create too much heat, depending on the thickness of the metal, you could create warping. You could dig in too deep. You could leave burn marks, and that's something we don't want to do. And the one thing I'll say about 3M is, and it's a pleasure to work for 3M, is we have a lot of options depending on type of metals you're working on. So this is for stainless steel. We have other products that work on cold roll steel, carbon steels, and same product, PSG, with 982C, but it doesn't have as much of a grinding aid as these do for stainless steel. So when I walk into a stainless fab shop, this is the first thing I'm pulling out, either 97 or 77. They both have PSG. They're at two different price points, but they're both very sensitive to the stainless steel and allows you to grind and cut at a cool temperature, which allows you to do a better job and leads to a better opportunity to provide a good finish with that second step in removing the grind marks.
Tim, we got our first question.
Sure.
Here it is. In a perfect world, is Cubitron II always a recommendation, or is there a reason that traditional ceramic is more appropriate?
No, in a perfect world, I'd always go with PSG. They're both the same. Okay, so ceramic aluminum oxide is ceramic aluminum oxide. What we've done is the shaping of it. That's the technology around it. I mean, 3M spends a lot of money on the science of all of our products. And the PSG is a ceramic aluminum oxide that's shaped, and that triangle type shape will allow you to cut on anything and leave you the best finish at depending on what the grit, but also the longest life and the consistent cutting. I'm gonna get a consistent cut rate on that disc. So to me, it's always going to be PSG because it's going to outlet. And I'll give you an example. So if I'm cutting with a 60 grit PSG product, the 987 or 787, I'll go up against our own product. We got we had other products. We stopped selling them on the disc part, but you would take a conventional disc at 60 grit. After just a few minutes, it starts cutting like an 80 grit, then 100 grit, and then 120 grit. It gets finer and finer. So the operator, he feels how it's cutting. So once it stops grinding like it did initially, you get great cut on conventional types of abrasives, but then it stops cutting. That grade gets finer. Whatever you start at is going to get finer and finer the longer you use it. Well, you'll find most operators, they'll take it off. Well, there's a lot of mineral left on that, but the mineral on a conventional abrasive is just going to be a finer version of that starting point. And so operators take it off. Now, PSG is going to keep cutting. Those triangles will consistently break down into more triangles, giving you that longer cut. So that 60 grit is going to cut like 60 for much longer. It's not going to cut like an 80 grit or 100 grit because it's always exposing that 60 grit mineral. It's in that shape, that precision shape. It's like a three-dimensional product. So to me, it's always, that's the first and only step that I would go for. Great question.
Good.
I hope I answered it. Okay. So two of our best products for working on stainless, just two different price points. 987 should last longer, but and I show these two because when we talk about factors affecting performance, there's a reason one won't work versus the other. You know, the 987C, these products I mentioned the shape, but you've got to give them pressure to dig into the surface and break down. Believe it or not, our sandpaper, it has to wear out to last longer. And that's a key to all abrasives, quite frankly, is you've got to get the abrasives to last. And there's things you do, whether it's machinery or tools, pressures, depending on all those factors come into play. If I'm not getting enough pressure to make 987 break down, you'll get something what's called capping. This is very common in our industry, where all of a sudden that sharp grain stops cutting, and you'll see in tip on stainless or carbon steel, you'll see silver on the face of your disc. Well, that's actually the metal that actually melts onto the mineral itself. So you're creating too much heat. It's not, the disc isn't breaking down. And quite frankly, this is very important. I was just at a place last week where they're having that issue, and we changed tooling, horsepower, and backup head, and I'll talk much more about that in factors. But a stiffer backing or harder backing allowed the disc to break down, because otherwise it glazes. It's called glazing, not loading. The disc isn't loading. It's not. You're not getting dust or metal in between the minerals. You're actually melting the metal onto the top of the minerals on the disc. Well, when that happens, the disc stops cutting, and then your operators take that disc off. And quite frankly, if you fix that problem, it's a great way to reduce your abrasives costs. I don't care what the abrasives are, if it's belts, discs, wheels, that's a major issue out there, and that's something we'll talk about in the factors. But there's a reason why then 787. So if I'm not getting 987 to break down, I'll go to 787, which doesn't have as much Cubitron II. It's more of a, I'll say, open coat, if you will, whereas the mineral's not quite as close together, but it still has that cutting ability. And because of that, it may allow it to break down and get to that end point. We want our abrasives to wear out. We do that, we'll save you a lot of money at the end of the day. Here's a little video, and I hope this comes through. I want you to look at the technique. This is one of the things I talk about everywhere I go on stainless, grinding stainless welds especially, because you're looking at that first step, but you got to do the second step. And the key, you'll watch how the disc is held according to the weld itself, and that's a black hard pad. We have a red that's even harder and stiffer. So those two are recommended, especially for 7-inch and even 4.5 and 5-inch discs. But watch the angle. If you can do this, now this isn't always, you're not able to do this all the time. You'll notice he's going along the path of the weld. He's not going perpendicular, he's going with it. And so those grind marks are now circular, but they're circular in a linear fashion, if I could say that. So you try to align your tool that way as you're grinding that weld down. Now also the angle of the tool, you only want to be 5 to 10 degrees up on an angle. Too many times people are come in from too steep of an angle. The steeper you go, the deeper the cut is on the metal, and now you're creating an issue. And then the other thing, you'll use more of your abrasives. So the flatter it is, now it's not perfectly flat, it's like 5/10, you're just barely picking it up, you're able to use a good outer third, at least, of the disc. What you don't want is see where the wear point is just the edge of the disc. That's a problem. Now you're paying for a disc, you're paying for a 7-inch disc, and you're just on the outer edge, you're better off with a 4.5 or 5-inch disc from a cost standpoint, because you're only using the outer edge. But you want to teach technique where that tool is angled up 5-10 degrees. You barely pick it up, and you're going to get best performance on the abrasive. Let the abrasives do the work. But the key here with stainless is going along the line of the weld if you can. That helps the next step. So the next step is if it's a portable tool application, you're using a tool. There's two types here. One's straight, one's right angle. The one in the middle is a right angle type setup, where when you put the belt on that wheel, your hands are going in the same direction as your wheel with the belt on it. The picture on the left, that's called an inline tool. There's a lot of those types of tools out there. And your hands are perpendicular to the surface. All you got to do is protect yourself from arcing your hands. You want your hands to go. You lock your wrist, and from a technique standpoint, to make sure that wheel goes straight along those finish lines. You don't want to have any arcing or curving with it. So that's why you've got two different styles of tools depending on the part, how big the part is. Tool in the middle is called match and finish. Again, that puts your hands in the same direction as the wheel spinning with the belt on it. The third picture on the right, that's just the flap wheel. So you got other things instead of belts on an expanded wheel or a cushion, air inflated cushion. You've got flap wheels you can use as well. But again, the key is going straight line. And then if you got a big part, flat part, you could be using a stroke sander, doing the same thing, just with a wide part. You got a flatbed it lays on, you pull it in and out, and use a stroke sander to apply the linear scratch. That's the second step. That's setting the grain. And then for us with belts, we've got Okay, we've got new and old. The new one, 947A, is PSG, Cubitron II, on the left-hand side. Just like the disc, it's precision shaped. It's designed to slice through. It's going to remove material faster with less pressure. It's got a grinding aid in it, and that's one of the keys for stainless steel. The one on the right, the 777F, that's a long-standing product of us, ceramic aluminum oxide. That's conventional grain though. That product has done so well. We've kept it in the line, and we use it for a lot of belt applications around stainless steel. Very popular product. It has a grinding aid in it. The only thing is it's just conventional abrasives versus PSG, but it still performs extremely well. And we actually have a lot of long-standing customers that have used this product for a long time. And the 747D, anything with a 7 in it is our ceramic aluminum oxide, just like our 900 series. And then the 747 is in that what we call PG flap wheel that goes on a straight shaft tool. It's a 3x1/4, 80 grit, doing the same thing you do with a belt on a wheel. So just multiple ways of doing the same operation. The key is following the three-step type system. Here's another short video of the inline tool. What's beautiful about us, we years ago we used to promote a air inflated rubber tire, but we moved probably about 7-8 years ago to an expander wheel. It's 25 diameter. It's a soft expander wheel. The belt slides on, and there's no bouncing whatsoever. Some of the problems you have with air inflated rubber tires, you put too much air in there and they start bouncing, and you create more work for yourself. You're leaving chatter marks. And our expander wheel works better, not just ours, but anybody else's expander wheel. That's a 3.5 by 15.5 belt. That's a standard size for that application, and highly recommended. And then after that, step 3, you're hitting it with a Scotch-Brite belt. Now, here's the difference in number 3 and number 4. The first 2 steps are the same. The most common finish is the number 4. Number 4 dairy, and that's with our medium surface conditioning A medium belt. We've got durable flex A medium. The key is the maroon color A medium grade will leave you that number 4 finish. Now, in addition to that, going from step 2, if you want what's known as a number 3, and all a number 3 is, you're still going to get a smooth finish, but it's going to have just a little rougher look to it, a little coarser look, because they're using a coarse Scotch-Brite belt instead of the medium. And that's the only difference. I've rarely seen number 3s. Now, some people think a number 3 is a number 4, but a true number 4 is with the A medium belt. A is for aluminum oxide, and that will give you the proper finish for a number 4 dairy. But if your spec does call for a number 3 finish, you're going from step 1 to step 2. Then your third step is on the same type of machine, 3.5 by 15.5. We have a smaller wheel as well for getting into corners on sinks, radius corners. But that's where the A coarse comes into play. Will leave you a slightly coarser finish on the stainless steel. And then after that, you can hit it with, well, here's another video, short video of the Scotch-Brite wheel. And all this is doing is taking that rough second step with the whatever belt you use, 947 or 777F. It's just making it smooth to the touch. And again, if you take a piece of cotton ball or pantyhose, you'll go across that. It'll be snag or burr free, and that's what the customer wants. But that's the process for finishing to a number 4 finish on stainless steel. Now, there's other products to use from the Scotch-Brite to give you different looks. Quite frankly, there's wheels you can use. If you want a brighter finish, again, there's a certain product to call out for number 4, but then you may have different specs from your customers. They may want a little different look. And so going top left to right, the top left is the belt we were just talking about, standard surface conditioning belt, A medium. That's your number 4 finish. But the middle is a wheel. It's called a metal finishing wheel. Well, that'll leave more of a satin look if that's what you're looking for. That can be run on a tool, depending on size, but also on a backstand. Picture to the right, top right, that's a combi wheel. Some people use that for smaller stuff. That's like a 3 3¼ inch diameter wheel working on a straight shaft tool. And then bottom right, that's again Scotch-Brite products that are ganged. That's about a 4 inch diameter on a straight shaft tool. Then bottom middle Those are flap wheels. Those are wheels. I'll show a good picture of them on the next slide, I think it is. That goes in our match and finish tool to leave different looks. Again, each one of these leaves a different look. Now, the big thing about Scotch-Brite, once you dial in what Scotch-Brite product you want to use, and for your finish, that's dialed in for good. You'll get a consistent finish each and every time using those products. The bottom left is bristle disc. We want to just take off weld discoloration. That's what those bristles will do. They won't do anything to the integrity of the weld. The weld stays there. It just cleans it up. Any weld discoloration and any kind of a coating is what the bristle disc will do in the bottom left.
Tim, I have another question.
Sure.
What is the difference between durable flex and regular?
Well, it's a great question. It's just we've got like 4 or 5 different types of Scotch-Brite products. A durable flex it's got a low stretch backing to it, where the regular surface conditioning has got a scrim backing. Durable flex is great for small belts, file belt type things where you have chunking. It doesn't chunk. It's got a different resin system. It prevents any kind of chunking, but the low stretch allows it to stay its size. So when you're working on file belts, if a belt stretches, all of a sudden now you have tracking problems. So durable flex has been around. It's a little bit thinner belt than the traditional Scotch-Brite, but it'll last longer. Different resin system, low stretch backing. Again, designed for belts like the file belts, like the expander wheel type belts. I'll even use them on stroke sanders because it's designed not to stretch, and you can have tracking issues on stroke sanders if the belt stretches too much. So great question. It's just a different product in our portfolio as an option to show customers.
It's a now follow-up, I guess, is durable flex equal to the IS belt? Is that the question?
IS belt. I don't know what the IS belt is.
Equal to the belt. I'm not sure what LS
No,
belt.
I'm not sure what that. Oh, LS. Well, LS is low stretch.
Okay.
So there is others. We have different resin systems. We got SE products, which have a different resin system and if I have sharp edges, I go with our SE product. But we have a low stretch within that. And the durable flex is SC is our surface conditioning belt. That's our original belt. That's still, and disc, that's still commonly used. Durable flex is the newer belt in the last few years that I tend to lead with when it's a belt operation. I hope that answers it.
I think so.
Okay. Pictured here are flat brushes. I mentioned flat brushes. These were developed just a few years ago to go. That tool is our match and finish tool. That's a portable tool used for stainless steel finishing. And again, you've got 6 different products here that will leave slightly different finishes. And it's just another example where you don't have to use a belt. If you like using a wheel type, these are flap wheels and great products. They don't smear. You got the tool running at the right speed, and it leaves a very nice finish. Slightly different finishes, and again, it's one of those you test to see which one leaves you the finish that you like as a customer. You know, what's the finish you want, and then once you do that, you've got it dialed in, and you're good to go. Here's some other products that are used for fillet welds, common applications out there. You know, from cartridge rolls, square pads, file belt sanders with different contact arms. You know, file belts can go down as small as a 1/8-inch wide belt up to 1-inch wide. Various applications, getting in tight areas, getting into radius corners, that type of thing. And then you got your unitized wheels. Rapid Cut we're showing as relatively new product that has PSG in it. That actually will get into corner welds and grind, believe it or not, on a right angle tool, 4.5-inch grinder. At the appropriate speed, that'll actually remove the weld and leave a nice smooth radius compared to using square pads or cartridge rolls. So it's just other options we have at 3M to try, and whatever serves your needs best, we choose that. So I always like to leave with a lot of options. I was hoping this would be a better picture. This is a fillet weld. It's a common system using a 1/4-inch wide belt on a 4-inch diameter wheel that's on a file belt, Dynabrase Dynafile or our file belt at 3M, 1/4 by 24, taking the weld down with one of our PSG belts, and then followed by a scalloped edge belt. I was hoping to have a better picture of the scallop. Scallop has got irregular shapes on the sides, if you will, that prevent cutting. Because one of the issues you'll have with this application is the edge of the disc will cut into the flat area and also the tube area and leave cut marks. Well, a scalloped edge belt, it's a little wider than the starting belt, and it actually folds up in the areas and prevents any kind of cutting. Scalloped, we use them on backstand machines, Bader type machines too, for we're taking a small part to that has a corner area you want to get into, and you can use scalloped edge belts. And then again, using the same 3-step system, the third step is a medium belt, leaving a number 4 finish. So that's a common application, our fillet welds in the stainless steel industry. And I mentioned the final blending if needed. People will use a hand pad on a hand block. Out there, they're using the 7446 or 7447 Pro, the two most common, used as a last step, and it talks about blending in transition lines if you might have those start and stop marks typically, and it's a good last step if you need it. There are other cleaners out there, but 3M has a stainless steel cleaner and polish, a spray can if you need it. There are many others out there as well, but just to show you some of the things that you can do, and this is typically at the end of your fabricating process. I'll touch on mirror finishes, and for those out there, if there's anybody out there that has to do a mirror finish on stainless, please understand it's a lot of work, but it can be done, and just following the appropriate steps. 3M handles it all the way really until the last step. 3M does not sell cotton buffs, but this is where if you want a true mirror finish, you're going to get to a cotton buff step, and to get there, you're going through some of your same steps that I've already talked about. And then once you get to actually a second step of sandpaper, you're not going to go to the Scotch-Brite step. You're going to go to what's known as Trizac A100. That's about a 180, 220 grit, and you're going to work your way down. We've got Trizac in various grades. It's a different grading system. I actually have a slide up here shows our grading system, but you've got to get down to the fact those scratches got to get tighter and tighter and tighter to get to that mirror finish. And Trizac is commonly used across the board in all industries when you have to get to that real fine RA finish, or in this case, a mirror finish, where you're using a cotton buff with compound. Trizac will get you there. So just understand it's many steps involved, and a lot of handwork with the cotton buff to work in that nice mirror finish. Well worth it at the end if that's what it calls for. But if you're looking for somebody's calling out a job for that, just understand what it takes to get to the mirror. And please call us. We can demonstrate any of this stuff in your facility. Okay. Any questions so far? Any more questions?
Nope, nothing right now.
Okay. I'm going to move into factors. These are all right. Abrasives are abrasives, but I'm here to tell you that there's so many things outside of abrasives, which could be one of your higher costs in your facility. But there's so many things outside of abrasives that affect the performance of abrasives. If you want to take advantage of the best abrasives, and I don't care if it's 3M or anybody else, there's a lot of good abrasives out there. If you're using somebody's best abrasives, what I'm about to talk about will affect those as well as ours. And moving forward. So, the operator to me is the first one. You got different operators out there. They got operators that have different preferences. All depends on what you do in your facility, how you control it, what the operators can do. They may have different priorities. They got different abilities. Certainly technique comes into play, and experience level. And then there's variability over the course of time. And then you got first and second shift variables. Some people like to do it this way in first shift. Some do it this way in second shift. So the operator is a key component in the success of abrasives. One of the things that I do, I've learned a long time ago, whether it's the customer using my products or a competitor's products, I'll look in the trash bin. I look at what you're throwing out, how you're throwing out. Are you getting to the end life of that abrasives? And if you are, great. If you're not, I'm going to bring it up to you, and then we'll talk about it, and we'll figure out ways to, if it's my product, we'll figure out ways to get better performance out of it, because I want you to keep using my best products, and that will give you the lowest cost for your abrasives and your process at the end of the day. but the operator is one of the biggest factors when it comes to abrasives. Work pressure. There's actually a little video here. Let's see if this actually may or may not have sound. But you'll have this operator. These guys are taking parts to a back stand, and you have two different guys here, and they may hold it differently and apply different amounts of pressure. So these are operator controlled. This where if you have a lot of parts like this is where you may want to look at robotics, where robotics can make things consistent from a pressure point all day long. 8 hours of doing this, at the end of the day, they're going to be holding that part differently, depending on how heavy it is and how much pressure they're putting in. That's what this is showing. That's where robots come into play. If you have a lot of parts like this, robotic applications are done very well. And 3M has, we've got in our Abrasives Method Center, our CAM Center we call it, we've got 8 to 10 robots, and we have engineers that specialize in robotics. They do that every day, and they come out in the field and work with customers. They also process parts at our facility back in St. Paul. We don't sell robots. We've bought several to use, not just there, but throughout the world for what that's worth. This is very important. So I carry notes with me, depending on the metal. If you look at the bottom left, there are recommended speeds. This comes from our engineers. There's recommended speeds to run your machines at, or even portable tools. The big note I'll talk about, if anybody does titanium, you notice the speeds are much lower. You got to be careful. There's so much heat involved, 2,500 to 3,000 surface feet. That's slow. If I'm compared to carbon steels and stainless, where you're 6,500 to 7,000. But if you can't do the same. You can't do titanium and stainless on the same machine, the same speeds. It's just, you're going to, titanium is dangerous to work with, create a lot of heat. You got to worry about flash fires, and you have to do the recommended speeds, whether it be portable tools or belts and belt machines. But these are very important factors when it comes to sanding, finishing, buffing. You'll see recommended speeds on the right-hand side for Scotch-Brite products as well. That's all based on surface feet. And I'm gonna add a little math to this. You guys and gals may have thought you're done with math in school and all that stuff, but with 3M, all of a sudden we're talking pi, and you got equations out there. So I apologize for bringing a little math into this presentation, but we have these calculators. It's just a calculator for surface feet and RPMs. And there are ways of changing speeds. You may have a fixed speed machine, but there's also a way to change the speed by changing the contact wheel. That's what we can do here. It's a chart. You're not going to have to read this. I'll send this presentation out, but you'll have access to this. But if you want to be at a certain surface feet, then you can figure out what RPMs you need to be, or what RPMs you have in your machine, and then you can change the diameter of the contact wheel, and that will change your surface feet, and that'll get you to the right point. And again, we've had proven successes for this over the years, and that's where this is all coming from in the recommended speeds. Abrasives, another thing is you got different factors. I just had a place last week so you got aluminum oxide, ceramic aluminum oxide, silicon carbide, you got diamond as well. One-dimensional typically is your sandpaper. You got a backing and a mineral sticking up. Three-dimensional is kind of like the Trizac. That picture middle bottom, that's a pyramid or that's a Trizac abrasive. So you get different. A100 is about 180 grit. You got different. You got dozens of minerals inside that pyramid. So as that pyramid wears away, the second part of the picture is where it's halfway worn. You still have dozens of A100 mineral particles in there. And as you get to the last, you actually get to the backing. The third part of that picture is where you've worn it out, but you've used up all that. The beauty of Trizac, especially when you're finishing or you need a certain RA, you've got to dial in a 20 RA, a 5 RA. Well, we get to a certain point with Trizac. Now all of a sudden you're going from part to part. I'll bring back what I said earlier, where conventional abrasives, 180 grit, it's going to start cutting like a 200, 220, 240, and then you'll take it off. But with Trizac, it just keeps going, keeps in this case blending or finishing at that A100 or 180 grit all the way through that pyramid, each one of them. So you'll get the same finish on part 1 versus part 50 versus part 100. 150, 200, whatever it is, and however long it lasts. And Tri-Zik works really well in your finishing applications. You get different backings. You've got open or closed coat. Closed coat's typically your coarser grades. Open coat where you have spacing in between the mineral that prevents any kind of loading. A lot of it happens in the woodworking market, to be honest with you. Or soft metals, aluminum, in brass, where it can load up. There's different things we do to try to prevent the abrasives from getting all clogged up. You have different backings I mentioned, and then surface coatings that we put on it, whether it be grinding aids or not. Those are all things to do with abrasives. Here's a grading thing just to show you, and there's an important factor to know. Years ago, if you can see it, the first column is the U.S. mesh. Typical, if I say it's 80 grit, we kind of just say it's 80 grit, but well, quite frankly, years ago, European manufacturers for abrasives came over and they came in with what's called the FIFA or P-graded products. It's not as critical on the coarse grades, but certainly in the finer grades. If I take you down to 600 grit U.S. mesh, if you look over to it, that's between a P1000 and a P1200. So where that comes up depends on how we grade our products. I may have a customer using, I had this happen where customers using a P1200, and that relates to a 600 grit in the abrasives that we were going to try. And I was trying to describe that to the customer. That's different grading system. That 600 grit US mesh is very similar to P1200 on the P grading. And then you have the Tri-Zik grading. Quite honestly, the Tri-Zik, the number next to the Tri-Zik is actually the size of the particle. A60 is 60 microns in size. And so just the opposite of conventional abrasives, where the higher the number, the finer it is. 1200, 2000 is very fine. And Tri-Zik is just the opposite. A500 is equal to 50 grit. So it's the size of the particle. And then A1 or A3 is equal to 1500 grit. And then you have the micron grading as well. And then you have Scotch-Brite. And Scotch-Brite's a mixture. It's not a pure grit, like an 80 grit. It's a blend of products, blend of minerals for what that's worth. And that's why they use the words instead of a number. And then something that also happens, you may, if you're using wheel type products, whether it be Scotch-Brite wheels, or even bonded wheels for that matter, if they get out of round a little bit, and all of a sudden you get a lot of wobbling, that can affect your finish. And so with Scotch-Brite, there's just ways of dressing it. You can use a diamond dressing tool to dress the wheel to make it smooth across it, or you can take a piece of stainless steel with a sharp edge and go across it. You'll take off the high parts and make it smooth again and continue to use that product. For right angle tools, very, very important is backup pads. I mentioned on our PSG, we want to have hard or extra hard, the red plate in the middle picture. That's a extra hard. We want that for our PSG products to work. What we don't want, the picture in the bottom middle with the thumb behind the roll-out pad, you see how flexible it is. If I'm running PSG products, that's something I do not want. I want to make sure I change that pad out. I just did this last week at a customer with 2-inch roll-out. They're running too soft, and they saw an immediate difference on performance of our PSG product with the extra hard roll-out pad, for what that's worth.
Tim, I have another question.
Sure.
What process or product would you use to get a number 4 finish on an inside corner of a stainless steel box where room and space is limited?
Well, the process is the same. It's a matter of finding the right products that can fit in there. And so we've got, coated products that can get in tight. Could be a cartridge roll getting into that corner. The process is the same, the stepwise 60, 120, 80, 120, that type 60, 100 as the first 2 steps. And then finding a Scotch-Brite product. We've got different wheel products, different angles to them that can allow us to get in tighter areas. So whatever the application is, it's just a matter of finding the. Now, I'll say this, it's not just the abrasive, but it's also the tool. If you use a right angle tool, straight shaft tool, and anything like that, the system's going to be the same. It's just finding the right type of products. And quite honestly, I'd have to see the product. I know the application he's talking about, but I got to see what tools you have, and then bring in the appropriate abrasives that match up to that corner. We'll have something to get into that corner. Could be a
Thanks.
file belt, depending on how much room you have. Thank you. And I just have a couple more slides here. Machine horsepower, this is very, very important. Just like in tools, you can be underpowered. Customer was at a couple weeks ago. They're running a 1/3 horsepower tool. We just changed it to a 1/2 horsepower tool, and the operator immediately saw a difference in the performance of the exact same abrasives they were using. Same thing with machines. If you don't have enough horsepower on your machines, then you won't be able to take advantage of the premium abrasives like 3M's PSG. And I'll say the same thing for electric tools. If you have electric right angle grinders, same thing. It's all amps. If you're running, lighter weight like 9 amps, you're not going to get the performance on your abrasives. You got to have at least 11, if not 13 amps, to get the appropriate torque for the abrasives to work under load. So horsepower is definitely a important factor when it comes to abrasives. These are some things that happen in machines. You got oscillation, different types of oscillation, which is the side-to-side movement, whether it be the part and or the machine. Those all affect the abrasives. Lubricants on your soft metals, especially aluminum, brass, if you're using some kind of a lubricant, but not even that. Stainless steel coil processing plants, they're running, I don't know how wide the coil is, 10 feet wide coil going down. They've got a machine that's got 4 heads on top, 2 to 4 heads on the bottom, and using a lot of coolant as that coil is going through and putting a finish from a 2B mill onto maybe a number 3 finish with silicon carbide type belts. So, and they're using massive amounts of coolant that extends the abrasive's life. Also, how long the abrasive is on the part, whether it's you taking the part to the abrasives, or if it's a tool going down to the abrasive, how much dwell time is, how much you stay in one spot. The longer you stay, the more heat you create, and you create warpage and create dig lines, and if that affects your finish. And then different work pieces, that all affects it. That just like the question was just asked, you got different shapes and sizes, and then getting into different things and different angles, and that's why there's different tools out there and abrasives to match. There's just different substrates. You're working on aluminum, stainless steel, titanium on the bottom. Just showing pictures of some substrates out there that are common, that are in our business and what we do. Inconel, very hard to grind on. PSG works very well, but you got to have the right pressure. You don't have enough pressure to make that abrasive break down, you won't cut through the Inconel. The Inconel is very, very hard. And quite frankly, if you get into hard metals, harder than 60 Rockwell, that's where diamond products come into play. 3M's got a full complement of diamond products that can run both wet and dry to work on hard substrates. Then you got your woods, soft woods and hardwoods. And lastly, it's my last slide here. We carry some tools. Myself as the abrasive specialist, we'll carry some things, but these may be some things you have. Tachometer, speed calculator formula tool, we got that. Durometer gauge, hardness of the contact wheel, that affects the performance of the abrasives, just like it does for extra hard and hard backup pads on right angle tools. Same thing for durometers of rubber or urethane on backstand machines, for example. I carry a PSI gauge measuring pressure for air tools, but the most important thing for air tools, this goes back to my 32 years of experience, SCFM is your volume of air coming to the tool. If you don't have enough volume, I find too many places that have 1/4-inch air hoses that they're running abrasive tools on, and 1/4-inch air hoses are great for assembly tools, drills, and that type of tool. When it comes to abrasives, you should have at least a 3/8 air hose. And the reason I say that, air coming through a 1/4-inch hose, it's only 12, maybe 13 SCFM. Well, the least aggressive tools of ours, our random orbital sanders, require 17.5. 1/3 horsepower air tool, right angle tools, they require 17 to 20 SCFM. So if you only have 12 to 13, you're already underpowered. I guarantee you your abrasive costs will improve if you put a different air hose on. You get more volume of air to allow that abrasive to last longer, because that's where you're going to get that glazing effect. Not enough power on the tool, not enough torque, doesn't let the abrasives wear out. Got to have torque. And for power tools, air hoses, the appropriate air hoses are needed for those tools to get one, the best performance of the tool, but also the best performance for the abrasives. I implore everybody to check that. I just did it last week with a customer. I have a gauge that measures SCFM. I can show people. That's why I know that 12 to 13 SCFM comes through a 1/4-inch airline. So 1/4-inch airlines, coil hoses are the worst things for your abrasive type power tools. I also carry a profilometer. We got a chatter mark belt splice calculator. I can see based on where splice marks, chatter marks, I can see if it's a splice issue. I already mentioned about looking into garbage, used discs, belts, wheels. I look at that, and then certainly application knowledge over the years. I've learned a lot from a lot of customers. All my experience comes from talking to customers and seeing what they do and asking questions. And I never tell anybody what to do, how to do it. I'll always reference, hey, I've seen it done this way. There's many ways of doing it. I've seen it done this way, and I'll make recommendations, but I certainly will never tell anybody how to do it. But I'll work with anybody on making everything work. And with that, that's my last slide, I believe. I've got a few minutes for questions. If not, you can send an email, and I'll be happy to answer any kind of question. I know I plan on sending this presentation out to Mark, and he can send it out to anybody who wants it. So I appreciate everybody's time this morning.
Thanks,
Hey,
Tim.
Tim.
Again, if anybody has questions.
This
Yeah.
is Kyle Heyman, local New Jersey 3M rep. Thanks for the presentation, Tim. That was awesome. Covered a lot of different topics. But I just wanted to throw out there for A&M personnel and customers, just understand there's a multitude of abrasive products and tools for different applications. But the relationship between 3M and A&M does allow for guaranteed trial orders and samples to best determine which fits your application. Just wanted to point that out.
Great,
Very
Kyle.
good.
Thanks. Yeah, and I do have one other question that was sent in related to that. It says, you said you're going into facilities. Is this the case currently if we need support in our facility to identify different abrasives and teach technique?
Yes, we are. 3M is allowing us to go. Now Kyle and I have to get we have to send a note in and let 3M know where we're at, more for contact tracing, such a thing. But we're allowed to go into facilities. We'll wear a mask, and it depends if you're letting me in. We have the ability of going in. I'm leaving tonight for a customer in central Pennsylvania, and we have certain protocol we maintain for ourselves with masks. But whatever you do, I have people, checking my temperature when I walked in last week. But we're here to help you. And if we can't, let's say you can't allow us to come in, we can do things virtually. I've done meetings where they've shown video, they've taken video and shown it to us, or we've done live feeds like a FaceTime call with Apple phones type of thing. Or if you do Teams, Zoom, you can show video. But we do things virtually where we have tech service people that will travel too. So if it's a application, a big application where we want to get our tech service people, which are fantastic, they're all engineers. Our engineers are your engineers, both in the field, but also at our CAM center. We have people send parts up, and our tech service people, the very same person that would come out to your facility, will do the testing and create a process for process improvements, or just to dedicate a process, from robotics to portable tools to time savers. We've got high pressure grinding. We've got all kinds of equipment in our CAM center up there to do things at the CAM center. So, but those same people will come out in the field, and they're traveling too. So we do have the okay to travel. We have to get a permission slip, if you will, from our boss's boss. But that's going on quite often. I haven't had anybody turn down yet. So yes, we are.
It's easy.
It's a long way of
Just
saying yes, we
have
are.
all the customers touch base with their local A&M reps, and then let me and Tim bring in the folks needed if we need any site visits from outside, Minnesota application engineers. And we need 48 hours notice just to get an approval. It is a minor process.
Great. Well, great, guys. I appreciate you taking the time, and thank you everyone who joined in. Again, in 2 days or so, you'll probably get an email from me to follow up with more information, and you can reach out to anybody at A&M if you need more. And thank you very much, everybody, and have a great day.